Welcome, everybody. Thank you so much for joining us today. We're super excited to be speaking with you about the role of carbon removal technologies in achieving net zero goals. We're joined by some wonderful panelists from Carbocrete, Project Vesta, and Spin, who we'll introduce in a little while. Before we dive into that, I just want to make sure my slides change. Before we dive into that, I just want to give you a quick overview of our event today. So we're going to be starting off with a little introduction to carbon removal and net zero targets. We'll start off with setting the stage on who Agendi is and why we're here talking to you today. We'll talk about the net zero landscape, a little bit more about different carbon removal technologies, and then we'll be diving into the good stuff with our panelists, introductions, and discussion. A quick note regarding our panelist discussion today, we will be accepting audience questions and answers. So please make sure to share questions throughout the webinar and submit them in the Q&A function that you should be able to see on your screen. That way we can get your questions answered. And then one other quick reminder that we are recording this webinar. So you will be sharing the link to that after our webinar. So first, I want to just start by introducing our Agendi team. My name is Daxi, and I'm joined today by Avatar and Arnaud. I'm going to pass things off to Arnaud so he can introduce Agendi and talk to you a little bit about what we work on.
Thank you very much, Daxi. I'm very excited to have all of you joining us today for what is already our fifth event. So we started 5 years ago in New York City. We are very fortunate to be able to do this in person again this year with our panelists. We were not able to host an event last year, of course, due to the pandemic, but very excited to be here with everyone else. So thank you for being there. Just a very brief overview of Agendi. So Agendi, for those of you who do not know us, we are a climate and sustainability consultant. So we help organizations, mostly large corporations, with their ESG program. So we do a lot of work around materiality assessment, understanding the key issues that our clients are facing. We do a lot of work also on the inventory side, tracking their greenhouse gas emissions, scope 1, scope 2, but more and more on scope 3 emission as well. And then we support our clients set ambitious targets and meet them. So we look at things such as improving the energy efficiency, sourcing more renewable electricity, joining programs such as RE100. Of course, many of our clients are interested in the Science-Based Target Initiative, which is why we decided to organize the panel this year on the theme of net zero. As many of you know, the Science-Based Target Initiative is going to launch a net zero standard on October 28th. And for us, we think that's going to change the landscape of the voluntary carbon market. We know since the IPCC special report on 1.5 degree, we know since Project Rodon that removals will be needed to restore our climate, and that's why we wanted this focus. Agendi, so you see some of the services that we offer. We have our clients in TCFD, understanding the climate-related risk is something that is very important for many companies, especially today in the US and in the UK. Where it's already becoming mandatory in the UK, and we know that the SEC is looking into climate risk disclosure. With that, I let my colleagues, Chelsea and Avatar, introduce the team today, which is Carbon Removers, of course, and I'm looking forward to moderating the panel after that presentation.
All right, thank you, Arnaud. So to start us off, I want to set a little bit of a context. As we all know, the latest IPCC report has set the stage that the climate is changing, and current climate policies and commitments are insufficient to curb global warming. Organizations need to plan for physical hazards and disruptive transition impacts. The latest IPCC report has shown that human influence has already resulted in over 1 degree Celsius of warming since pre-industrial levels, And that warming is not distributed evenly across the globe. Some areas have already warmed over 2 degrees Celsius. What this means is that there's irreversible tipping points that are accelerating climate impacts, from biodiversity loss to increased natural disasters. So this means there's a need for dramatic climate action. A growing number of leading global companies are starting to take that action by making net zero pledges, but their approaches have been a little inconsistent. So the good news is that greater than 20% of major companies, which represent nearly $14 trillion in sales, have already made net zero commitments. You can see some of the companies that have taken that step forward up on your screen, but this is not an exhaustive list. There are many, many more. So that is wonderful, but there are the inconsistencies in those corporate net zero targets are a serious problem, and they're inconsistent in a variety of ways. First of all, the emission sources and activities that are included within those net zero pledges are simply inconsistent, as well as the timeline by which those net zero pledges are going to be achieved, as well as the mitigation methods that are going to be utilized in order to achieve those targets. So you can see that it's great that there's net zero pledges that are being made, but those inconsistencies are a problem, and it's drawn a lot of public attention. Various news outlets have started to highlight how we need to be moving towards net zero pledges, and how we need to be making sure that these commitments are truly aligned with science. So we want to start off by kind of setting the stage of what does net zero even mean? How does it compare to carbon neutral? In order to truly discern meaningful targets, it's critical to understand this distinction. So first off, carbon neutral essentially means that you don't necessarily have to mitigate your emissions to the fullest extent possible. You can see in this graph on the left that emissions can exceed the Paris-aligned pathway, which is the dotted green line. And then ultimately those emissions are simply offset. With a corporate net zero strategy, you can see that the emissions are in line with 1.5 degrees Celsius pathway, and that ultimately those emissions are neutralized via CO2 removal. So there's some really critical distinctions here, and I think it's really important to make sure that those two terms are not being conflated. We're really in favor of these net zero targets that are going to make some drastic impacts and really help to fight climate change. So I'll pass things off to Avatar, who will talk to us a little bit more about those net zero strategies.
Thanks, Jaxie. So currently, the main framework that companies use to ensure that their climate commitments are credible is to use the framework provided by the Science-Based Target Initiative. To date, over 1,800 companies have committed to taking action with science-based targets. And of those companies, 785 have committed to targets that keep them within a 1.5 degree future, which means they're aligned with the Paris Agreement. The Science-Based Target Initiative is also currently developing a net zero standard, and they started this process back in September of 2020 when they released their first foundations paper. They just recently started the second consultation phase, and they're planning to launch the standard this November to align with COP26. The GHG protocol, which is used by many companies to ensure that their greenhouse gas accounting is credible and comparable to other companies, are also currently developing a new framework to ensure that land sector activities and carbon removals are incorporated into those greenhouse gas inventories. They started this process at the beginning of this year, and they're planning to complete it by sometime next year. And so when you boil down a net zero strategy, there's three main components that need to occur. The first is to abate emissions as much as possible inside of a company's value chain. This means cutting emissions within the company's own operations, as well as engaging with their suppliers and consumers to ensure that emissions throughout their value chains are abated to the fullest extent possible. The second step, while this abatement is occurring, is to use compensation methods to reduce emissions outside of their value chain. This can include selling low impact goods and investing in renewable energy technology, as well as energy efficiency measures. And this enables the company to balance out the emissions as they're working on ways to abate them. However, this is more of a means to an end and is not included in the final net zero strategy. The final step is to neutralize these emissions by developing carbon sinks, either inside or outside of a value chain, by pursuing nature-based and technology-based carbon removal technologies. This allows companies to to remove the carbon from the emissions that they're unable to abate. So the main difference, as Jaxie said earlier, is that net zero ensures that emissions abatement is achieved to the fullest extent possible. And the next step is to look into carbon offsets. The main two types are carbon avoidance offsets and carbon removal offsets. Avoidance offsets prevent additional carbon from being emitted into the atmosphere. They're not included in a net zero future because they do not ensure that, they only ensure that more carbon is not emitted, but they do not remove the carbon that's already been emitted. This can include renewable energy projects, energy efficiency projects, as well as deforestation prevention projects. Carbon removal technologies and offsets directly either remove or capture carbon from the atmosphere. And these are included in companies trying to achieve a net zero target. The main three types are nature-based solutions, including the coastal carbon capture that Project Vesta will be talking about today, technological solutions such as Carbocrete's carbon-free concrete, and a combination of nature-based and technological-based solutions such as biochar. And now I'm going to pass it on to Arno to introduce our panelists and begin the panel discussion.
Thank you very much, Avatar. So I'm very pleased to welcome Ui Wenchan, who is Director of Sustainability at SPIN. She basically is the reason why we have this panel today. When we were working with SPIN, we were looking at ways to help SPIN really go beyond carbon neutrality and looking at solutions that existed already on the market when it comes to removal. And so we had a lot of sessions discussing some of the ventures that SPIN would want to support, and that's how we started working together with Project Vesta and with Carbocrete. So thank you very much, Ui, for this support. The second panelist will be Kelly Earhart from Project Vesta. Kelly is co-founder of Project Vesta, and she will very shortly introduce you about that technology, which is really cutting edge and has a huge potential. And then we are pleased to have Travis Bradford, who is a strategic advisor at Carbocrete, a company based out of Montreal. But Travis is here in New York with us today, and will be presenting Carbocrete solution, which has also a significant impact on reducing greenhouse gas emission from the concrete and the construction sector.
Wonderful. I guess so. We're doing quick introductions. So we'll be brief because I want to talk a little bit about the whys of what we do when we get to the whole panel. But just to give you a sense about what Carbocrete does, to put it in context, Carbocrete is the cement-free, carbon-negative concrete solution. We can go to the next slide. I guess the important thing to understand is how big a deal cement and cement-based concrete is in global emissions. 7 to 8% of global emissions. It's also cement. It ends up being a major part of that problem. In fact, nearly all of the emissions in concrete, cement-based concrete, comes from the cement. Pound for pound, it emits as much as you put into the product, and it's expensive. Next slide. What we do is we get rid of the cement. We use steel slag, which is we use steel slag, which is an industrial waste product from the steelmaking process. It's not useful for really much else. It's hard. It's a difficult material to work with, but we use that in order to bind the concrete together instead of the cement. And in order to make it bind, we use carbon dioxide as the curing to make that bond form stronger than the cement-based concrete. Next slide. We do this in precast and masonry today, although we have a technology roadmap that covers lots of different types of concrete products. But today we do mostly CMUs or blocks that you can see on the screen. That's one of ours. Pavers and retaining walls. Next slide. I think it's important because, and I think Avatar and Jaxie did a really good job of sort of laying this out. It's important to have both abatement, and by eliminating cement, you're eliminating nearly all the emissions of cement-based concrete. So we get a huge amount of abatement from an 18-kilogram CMU or concrete block or cinder block, however you like to call it. That reduces 2 kilograms of CO2 that would have otherwise been in the product. And because we cure with CO2 as part of the bond formation, we can put up to 1 kilogram of CO2 into every one of those blocks. So that's a 3-kilogram swing on an 18-kilogram block. You can begin to see the impact. Next slide. Last slide. It's important, and we'll talk about this in the panel, but it's important that this is based on a process that has commercial value. And so what our product is it allows us to do a number of things that manufacturers like. We cure our product in 24 hours instead of 28 days, which has a huge working capital benefit. I mentioned the carbon negative aspect of it. The product is stronger. We form better bonds through our curing method, and the material cost on making this is cheaper. So if it almost sounds too good to be true, and so there's certainly lots of challenges in deploying it, but the fact is if you can make something that's both cheaper and more environmentally beneficial by such a wide margin, that's a good foundation to work from. So I look forward to talking about that more as we go through the panel.
Great, thank you so much. So I'm Kelly Earhart from Project Vesta. At Project Vesta, we're working on what's called coastal carbon capture, which we believe has a chance to be one of the most scalable and efficient ways to do permanent carbon dioxide removal. So at Project Vesta, we're working with nature, and one of nature's best systems for regulating carbon cycles on planet Earth is the oceans. So since the Industrial Revolution, the oceans have absorbed about 30% of our carbon emissions. And as a result of that, the oceans have become 30% more acidic. It turns out that by reducing acidity, we can help the oceans safely store more carbon dioxide as bicarbonate. And so the key question that we're asking is, how can we reduce ocean acidity? And we have a solution for that. The solution is by taking olivine sand, which is a natural volcanic mineral that is abundant on planet Earth. It actually makes up over 50% of the upper mantle, and there are trillions of tons of it at the near surface. We grind it into a sand, and we bring it to coastal areas where it dissolves. There in coastal areas, the wave energy increases the carbon sequestration by causing the olivine grains to grind into each other, which increases alkalinity of the ocean or lowers the acidity and removes carbon dioxide from the atmosphere. And this process is based on billions of years of research and development by planet Earth. You can move to the next slide. What we're working on doing is just accelerating nature. So the graphic that you see on the left here is what's called the long-term carbon cycle. Typically, when we think about carbon sequestration, natural carbon sequestration, namely, we think of tree planting, which is fantastic. That works with the short-term carbon cycle. The long-term carbon cycle is actually what's responsible for what is 99% of all carbon on Earth actually being stored in rock. So that process typically takes millions of years. And what Project Vesta is doing is accelerating that to a human relevant timescale, kind of on the same timescale as the short-term carbon cycle, to remove carbon from the atmosphere and deacidify the ocean. It has a number of co-benefits. One of my favorite is that it has the potential to really help protect coastal communities. So as frontline coastal communities are experiencing climate change and the effects of sea level rise and erosion, we are working to work with them and replace some of the sand that's used for coastal replenishment with olivine sand so that we can treat both the symptoms of climate change, erosion and sea level rise, as well as the root cause, removing carbon dioxide from the atmosphere. It also mitigates ocean acidification and is incredibly scalable to many gigatons. It doesn't compete for arable land or water, and luckily we don't really have to invent any new technology. We can work with the efficiencies of the shipping, mining, and transportation industries to move these rocks around the world to sequester carbon dioxide naturally. That's actually all I have for right now, but excited to speak more about where we are at in the process of our research and deployment.
Good morning, everyone. I'm Huey Chan. I'm the Director of Sustainability at a micromobility company called Spin. Spin is a unit of Ford Motor Company's Ford Mobility unit. Our goal is to provide sustainable urban transportation via micromobility, so e-scooters and e-bikes throughout the United States, Canada, and parts of Europe. Spin sustainability focused has two broad areas. The first is really focused on providing a sustainable mode of transportation to riders. And that involves thinking about the sustainability of Spin's operations and the sustainability of the vehicles that Spin is providing in cities and campuses. The second aspect that we really focus on is the sustainability of the transportation ecosystem. We want to encourage and enable people to get out of their cars and onto more sustainable modes of transportation. That includes micromobility, but it also includes complementary modes, including walking, biking, and connecting to public transit. We believe that unless we can get people out of their cars, it almost doesn't matter how sustainable we make our offerings, because we won't have the scale of the impact that we want. So this is actually a really, really important focus of the work that we do. Spin also has a commitment to be carbon negative by 2025, and that is going to be done through a combination of the work we do to enhance the sustainability of our operations and to reduce the emissions of our operations and our vehicles. We're also, through mode shift, working to avoid emissions from being created by cars. And the last aspect is what we're here to talk about today, which is really how do we remove carbon from the atmosphere. So today, Spin is a carbon neutral company thanks to our work with Agendi. We spend a lot of time measuring our carbon at the beginning of the year to get a baseline of where we are. And we did this across all of our scope 1, 2, and 3 emissions. We focused on obviously reducing our emissions and then using RECs and offsets, getting to carbon neutrality. Spin is also the first micromobility company to make our carbon accounting transparent. We believe that disclosure is really important to kind of escalate the ambitions of the sector as a whole to making micromobility a sustainable offering. Of course, one of the things that Spin also did is we joined the Climate Pledge. It's now over 200 companies, not just 100. They announced earlier this week. And companies that sign on to the pledge commit to getting to net zero by 2040, 10 years ahead of the Paris Climate Agreement. So one of the things that I've been really focused on at Spin is thinking about how to continue to do the reduction work that is really critical internally to abate emissions, work on helping the transit ecosystem avoid additional emissions, but then working with companies like Carbocrete and Project Vesta to enable us to remove emissions from the atmosphere. It's almost there.
Thank you very much for this presentation of your 3 projects. So I will start with Spin. My first question would be, so you've been working with Project Vesta and Carbocrete, and I'd like you to elaborate a little bit more the context of that partnership and how did you start working with them and why did you choose these?
Sure. So when Spin first started thinking about carbon removal, it's a really complex world of different technologies, very technical. So one of the first things that we decided to do was actually to work through Stripe Climate. Stripe Climate aggregates contributions from thousands of companies, and they basically work with a team of scientists to select companies and technologies that they believe have the ability to scale and have impact and help remove carbon from the atmosphere. I also decided that in addition to that, I wanted to find a couple of companies that are aligned with Spin's mission and our work to promote sustainable cities. So when our node heard, we had already been working with Agendi and our node on getting to Spin to being a carbon neutral company. So when he found out that I was trying to identify the appropriate companies, he made the introduction to Carbocrete and Project Vesta. And the reason why I love these 2 projects is because one, as Travis mentioned, concrete is the most prevalent man-made material. It is so critical to building the infrastructure, the buildings, the roads that we need and rely on in our cities. But it is really, really carbon intensive today. Cement contributes to 7 or 8% of global CO2 emissions. So when you have the most prevalent man-made material, if you can use that to then trap carbon, and on top of it, use a industrial byproduct, we can really, really enhance the sustainability of the cities, which we know are going to continue expanding since the world will continue to urbanize. What I loved about Project Vesta is that it is taking a natural process, using something that is naturally abundant and utilizing a natural process to enhance the ocean's ability to trap CO2. A lot of the markets that Spin operates in is in coastal cities. Spin is also headquartered in San Francisco, which is a coastal city. And we know that many of the places where we work today will be impacted by climate change and impacted by sea level rise. So doing something with Project Vesta that enhances coastal resilience was also something that was really attractive to me. So a huge thanks to Agendi for making the introduction. It's been great so far.
Thank you. So my next question will be for both Kelly and Travis. So there are many carbon removal solutions that exist today. It's a very complex landscape. How does your solution particularly fit into that landscape?
Sorry.
Please.
So I'll start by saying that I think that it's often when we're talking about carbon removal and climate change, we want to know what's the solution, what's going to fix it. And it's very clear to, I think, anyone who's spent a little bit of time looking at the issue that it is going to take a large portfolio of solutions all deployed at once in support in a coordinated collaborative landscape to fix climate change. So just to preface it with that, that very in support of the many different carbon removal and avoidance technologies. Project Vesta is different than many technologies in that, in the nature-based landscape, many of our nature-based carbon removal solutions are all reversible carbon removal. So what that means is, as I mentioned, they work with the short-term carbon cycle. So when a tree absorbs carbon dioxide over its lifetime, it eventually dies and re-releases that carbon dioxide back into the atmosphere. The same thing will happen in a soil-based system. And so at Project Vesta, when we capture carbon dioxide through this natural process, we're actually able to permanently fix it for what will be likely millions of years in rock. And so that is a big differentiator. Another is the cost. So outside of the sort of nature-based solutions, when we look at more permanent carbon dioxide removal solutions, we think about direct air capture, for example, which is an incredible technology, but it is quite expensive still. And so with direct air capture, we're talking about a couple $100s per ton of carbon sequestered. And at Project Vesta, we're aiming to be at $35 a ton in the next few years. So we think it'll be really competitive, which will allow for ultimate scale. And then I guess the last thing I'll say is the knock-on benefits. The reversal and mitigation of ocean acidification, which is such a big issue in the world today, is a big one. And then, as you mentioned, working with coastal communities to try and support them in their resilience efforts is another.
So we like putting CO2 into rocks as well. In fact, we wholeheartedly support such an approach. I guess one of the distinctions here is I like the theme music. One of the distinctions here is what we find is whenever possible, particularly when trying to alter sort of man-made emissions through that in capital-intensive industrial architectures. If you can figure out a way to create a revenue model out of that, that's really important, right? So if you can figure out in any way so that you can help pay for those abatement or removal credits as part of a cost-effective, a cheaper technology, that's actually really, really important. It's not going to get us all the way. It's only going to work in certain industries, but to the extent that you can actually leverage the economic infrastructure to help subsidize in effect some of the removals and end up with a better, cheaper product in the end. So I think the revenue model here is really important. I think when you think about some among the different ways that you can do that within the constructs of building materials or other sort of, and even specifically within the concrete industry, you have to think about sort of the range of technologies and the impacts. And I think there's kind of three dimensions that you kind of want to think about in terms of that. First is, are you working with a technology that can get you to a truly carbon negative platform? Because it is not probably going to be helpful to make a substantial investment in something that is going to get you part of the way, but is going to then reinvest in an architecture, delivery architecture of vast quantities and weight of building materials that only gets you part of the way there, right? We have to get to negative and going halfway to zero And then building a big architecture around that means that we have a whole lot more work to do later. And then in the meantime, you have a bunch of sunk costs of the existing infrastructure that you're going to have to kind of deal with economically. The second is that technology, like I said, there's a revenue model, but is your fundamental cost structure cost effective? Meaning, does it take a whole lot of additional cost or additional capital in order to bring your solution to market? Because if it does, you may find that you're constrained in some effect by access to capital or access to customers. And sure, having a trajectory into cost negative is good, but if it's too expensive today, you may find that you never raise enough capital to be able to get there. So you need to start with something that's relatively cost effective, and hopefully over time it'll get even more cost effective and even cost dominant as the scale of your solution grows. And the third is how big can you scale your solution, right? It's like, how large does the market support your innovation? And there are lots of great technologies. There are some people who believe only gigaton scale solutions should be sort of invested in. I think, like Kelly said, I think there's a lot of solutions here. And I think it's going to take a portfolio of solutions to get to the full thing, but it still has to be big enough to justify the investment dollars and the financial market support, the capital markets, to be able to support whatever your technology is. So you really need to show that there's some scalability, that it'll have a meaningful impact. What is meaningful? It's different for different people, but it's in the millions of tons, tens of millions, hundreds of millions of tons range that it needs to be as part of the solution set. If you can find things that check those boxes, you found a really good technology. We think that Carbocrete's technology checks all those boxes. And while we think there are lots of, again, great technology pathways in concrete, we think we're the only ones that check all of those boxes. And we think that's, and therefore, we think we've got something pretty valuable, and we appreciate the validation that Agendi and Spin have given us to sort of suggest that what we're doing does check all the right boxes in pursuit of that goal.
Thank you, Travis. I have another question for Kelly and yourself as well. There is some skepticism on carbon removal, sometimes questioning the environmental integrity. There are organizations wondering whether we should apply the precautionary principle when we start to. Some people will say we are playing with nature. I wanted to know if this is one issue that you are facing with your own solution, and how do you answer that? Yeah, maybe starting with you, Kelly.
Sure. I would say that the industry in large is facing this criticism, right? At Project Vesta, we actually haven't seen that much of it because we're in a pretty early stage of deployment and selling carbon credits and really being in the marketplace. However, the conversation in the industry at large is a very important one, and it has merit. There's serious concern to be had about sort of writing a blank check for future emissions to continue. However, there's also the fact that we have a lot of fugitive emissions in the atmosphere, and we, as Jaxie laid out for us, don't really have the option to not remove carbon dioxide from the atmosphere anymore. Even if we cut to pre-industrial levels today of emissions, we would still see the world continue warming. So we do need to remove carbon dioxide from the atmosphere. And I think that's why it's really important that organizations like Agendi exist to help companies see how they can do both, how they can begin avoiding emissions while also investing in carbon negativity. The other thing that I'll say that is a lot of people ask, well, are we messing with nature? Which I find to be a sort of interesting question to be asking, considering since the dawn of civilization, we've been messing with nature. People like to question, well, what is geoengineering, and is this a geoengineering effort? And I think we often forget that, in some ways, we've been geoengineering since we began agriculture, altering natural cycles to do what we want with them. And I think we, as a species, have this opportunity to kind of look at what's been done and to be wise ancestors for the future and set systems in place, set markets in place to be able to rebalance our carbon cycle so that the Earth can continue, moving forward in a fashion that supports life on Earth. So in many ways, it's really just not a question to whether we can or can't do carbon removal. I think how we do it is very important, and I think what voices we include at the table is very important. A key piece of the pluralism of the solutions that are deployed, I think, is making sure that the voices of underserved communities and historically marginalized peoples are heard, and that those solutions that are deployed are also supporting the groundswell of their thriving, not just the technological fixes. And so that's why at Project Vesta we have a pretty deep social sciences work stream, so that we can ensure that we're working with stakeholders at every level of the chain, so that their voices are heard, that local coastal communities are supported, and then I'd say the last piece is broad social license for how we interact with the ocean is a key thing as well. We just finished authoring a draft of the ethical code of conduct for coastal carbon capture with the Aspen Institute, and we hope that carbon removal companies worldwide will really put more thought into how we can engage with communities around this issue.
Sure. I mean, to comment on that, actually, I think the answer to whether things are safe is partly, I certainly commend the social science aspect. There's also a hard science aspect that I think is important, and I think it's increasingly coming up in this. When I was helping to launch the Carbon War Room, we did a lot of work with, and geoengineering was really a big topic of debate at the time and concern. And we worked with the Royal Society in the UK to develop some methodologies to try to preemptively and precautionarily do the science related to some of these methods. So I commend any effort in to try to get ahead of that as well, because I think we have to answer these questions, and I think doing nothing is also an experiment with nature. So we don't get to start with a fresh green field. We have to actually work with the circumstances that we found. But I think ultimately, so in our particular removal technology, our measurement ability is much simpler, right? We have a closed curing chamber in which we put CO2. We have blocks come out. We measure the CO2 in, the CO2 out. It's a fairly straightforward process, and it's mineralized in the product. So it's and again, it makes it into rocks. It stays for a very long time. I'm not sure millions of years, but long enough that I think we can push that debate off a little bit. Thousands of years, hundreds of thousands of years will probably be enough. But I think that if you do the if you sort of want to have a science-based approach, this is where I think the transparency that Wen is talking about, is important, because if you aren't transparent, people are not going to have the right information about this. So you have to be transparent about the technical aspects. You have to be transparent about the delivery aspects and the economic aspects of what you're doing. And without that, then the system will sort of fail to deliver the right solutions to the right place. And that's the basic principles of economics: is markets work when they have the right information. So I think that if we commit ourselves to science and we commit ourselves to transparency, those are the guiding principles that will get us to the right solutions.
Rebounding on the transparency aspect, which is super important. One thing that your three companies have in common is that you are leveraging life cycle analysis in your work. So I think it would be interesting to know from each of you how you are using life cycle analysis and how it informs what you are doing. And I think it would be also interesting for the audience that might be asking this question themselves, when we think about all the energy that might still be required to implement your solution. So just touching on that aspect would be very interesting. Maybe.
Yeah, I'd be happy to start. As I mentioned, one of the things that we're really focused on is making sure that our operations and our product is sustainable. And one of the tools that we're using to help us with that is the life cycle analysis. We worked with MIT, with the SHINE team at the the Material Research Laboratory at MIT, to look at all phases of a scooter life cycle and an e-bike life cycle, from the raw material extraction, the manufacturing, the transport, the use phase, which is really kind of linked to Spin's own operations, and then how we treat the vehicles at the end of life. We did a first LCA back in 2019, which honestly showed that the micromobility industry wasn't as sustainable as we wanted it to be. And that really pushed companies in the micromobility space to look at how we can make our products more sustainable. So in order to tackle the raw material manufacturing and transport phase, we realized that we had to make our scooters more sustainable, that we can't have these vehicles only last for a few weeks or a few months on the street and then need to get disposed. So we've really focused on, the industry has really focused on increasing the durability of these vehicles. So you can divide the kind of emissions from the cradle to gate, so to speak, portion of the life cycle across more distance traveled. So that brings us to the use phase. And during the use phase, the scooters have to be charged, the scooters have to be deployed. So it really comes down to the sustainability of our operations. So Spin looked at what we did. We were using gas vans. We are working to transition now to a fully electric fleet. It is taking time because electric vans are not readily available in the United States today. We're waiting for Ford's e-Transit. We've got a bunch of vehicles on order, and we're really just waiting for those vehicles to become available. In the interim, we've switched to using scooters with swappable batteries that can be that we can use smaller operations vehicles, things like e-cargo bikes, to swap out the batteries because we no longer need to take the entire vehicle back to the warehouse for charging. And then the other aspect is, of course, the charging. These are electric scooters and electric bikes that we're deploying. So we have committed as of 2020 to only use renewable electricity to charge. We're purchasing renewable electricity directly from local utilities where available, and then also purchasing renewable energy credits. We are also looking at things like how we repair our vehicles to extend their life. And we're also we're also harvesting parts from worn or decommissioned scooters that can be used to repair our vehicles. And that reduces the emissions needed to manufacture new replacement parts. Lastly, all of the parts will at some point be worn or damaged and will need to be disposed of at the end of life. We are working with R2 certified responsible recyclers to make sure that at least 98% of the contents in our scooter are processed, broken down, and mined so that they can re-enter the manufacturing process and be made into new products. So we are continuing to, learn from our life cycle assessment to look at other opportunities to improve the sustainability of our vehicles. So one of the kind of key areas that I want to tackle next is to think about how we can incorporate more renewable or sustainable materials in the design of the vehicles itself. So using renewable or recycled content. So I'll just pause there. I'll add one more thing. We are publishing a sustainability white paper today that actually goes into a lot more detail about our life cycle assessment. So if you're interested, I would encourage you to look for it. And I'm more than happy to send a link to our node later to share with this group.
That's great. So at Project Vesta, and I appreciate you bringing in the component about the hard sciences, and I'll just come back to that question for a moment and just note that our work is based on 30 years of research that's been done in the laboratory, and what we're doing is bringing that work in the laboratory into real world testing and viability demonstrations. And so we have a full-time team of 7 PhD staff scientists that are working on our life cycle assessment, developing new methodologies for measuring carbon capture in the ocean's ecosystems, and really understanding the full suite of ecological effects, what happens when we introduce olivine to new areas where it's not already found. And the life cycle assessment component is actually quite elegant for us because we're able to work with the efficiencies of an industry that has historically really insulted the planet, mining, milling, shipping, transportation, and actually use those to deploy a solution that is supportive to the planet's future health. And so currently our life cycle assessment is that for every ton of carbon that we emit in the process of mining, milling, and transportation, we're able to sequester about 20 times that. So the process is 95% efficient. We're working on different levers that we can pull to make that process even more efficient. So that's things like partnering with folks who are working on decarbonizing shipping, more sustainable mining practices. our current mining partners and supply chain partners operate with 100% renewable energy at their mining operations. And we hope to continue that practice in the future and even incentivize it as a more widespread practice. So that's really important to us as we look to scale. But I think that is one of the very elegant things about the solution is we're not talking about an industry of the size that hasn't been deployed before, right? So when we're talking about billions of tons of carbon removal with this solution, that's about a quarter of the size of the coal industry, which albeit is large, but climate change is a very large problem. So we think it's totally manageable, and are also working on increasing the efficiency even more beyond that 95%.
Sorry, I'm still sort of blown away by the 95% number. I think that's fantastic. I can't wait to see how fast that can be deployed. And I talked through our LCA. I mean, if you looked actually at our LCA analysis, it wouldn't be much different than that very simple slide that I put up with 2 kilograms per 18 kilogram block of abatement and up to 1 kilogram. One of the nice things about our process is that it's actually, we can control the amount of CO2 that's put into the product. And the reason, I mean, you might say, well, wouldn't you want to just do more, right? Do the most you can possibly do. Technically, actually, that's helpful. The more slag we use, the more CO2 uptake we get, the better. And pulling both of those levers actually creates stronger product. But there are also cost considerations, right? And it depends on the value of the CO2 benefits that we're creating. And there's lots of ways you can monetize it. We think that the voluntary credits market right now is by far the most helpful. It's clean, it's clear. It takes visionary people like Spin to sort of recognize the inherent value in these sort of what I would say is boundary condition processes, whether they're the geological storage or the if I'm mischaracterizing that, I apologize, but the building materials mineralization routes, right? Somebody has to value those things. In the cases in which someone does value those things, and it could maybe the customer values those things, the masonry block producers or the customers themselves or other visionary companies, that if they were, if they're willing to sort of support the process, we can turn the dials and increase the CO2 uptake by quite a bit. And we continue to work on the research so that we can do that for lower and lower cost. But there is ultimately, there is a cost associated with it. But if the value is higher, we'll make that argument. To the extent that manufacturers are very, very worried, particularly in the early rollout stages, about cost competitiveness, which they should be, right? You don't want to have solutions where people, either adopt them and then find themselves in a competitive disadvantage and can't sell their product, or just won't adopt because they're concerned about the same thing. So what we have the ability to do is we can cost engineer the product in the early stages so that we get a meaningful amount of removal benefit. And then as we can monetize that removal aspect even more and more, we turn the dials and we can put more CO2 into the product. So that gives us and we have a nice range with which we can work there. So but again, it's for us, the actual calculation is simpler just because we use this closed chamber method. And we're happy to share that with anybody that's interested.
Thank you. We only have 10 minutes left, and then we want to take questions from the audience. But I have one final question for both Project Vesta and Carbon Creek. When do you see yourself moving from R&D to pilots or industrial scale projects? So what's your timeline for that?
So right now we're working on our first field deployment, which is in the Northern Caribbean. And with that project, we're in the early stages. We've just got our first results back from the initial baseline sampling process, which was a process that required a lot more than we thought, because we had to engineer new ways to sample based on the markers that we're testing for. So that project is underway. We hope that we'll have Olivine on the beach there in the next 6 to 8 months. But alongside that, we're also working on different field deployments for more of the coastal nourishment method that I was speaking to, where we're working with coastal communities to replace a portion of their coastal nourishment sand with olivine sand. And with that, we're working with three communities on the eastern seaboard of the United States. And so we will be hopefully deploying that in the course of the next year. But these are all very small deployments. And it's important to note that I mentioned before, we're working on 30 years of lab-based research, many publications. And what we're trying to do is create an integrated assessment model so that we have a really clear picture of the safety and efficacy of deploying coastal carbon capture at scale. So there's a number of things that we are looking to validate. One is the ecological safety. So we're monitoring at all of these sites, as well as in mesocosm experiments. And mesocosms, for those of you who aren't scientists, which is probably most of us, is a small scale sort of tank or a very large scale tank that's mimicking a natural earth system. And in that, we can create the conditions that mimic an olivine deployment in an ocean environment. So we're doing mesocosm experiments, we're doing large scale modeling experiments. We are in partnership with the Army Corps of Engineers to use their supercomputers to monitor and predict sediment transport, how grains move throughout the entire ocean. And then at our field sites, we're measuring a number of variables to understand the ways that ocean alkalinity changes, whether there's any nickel releases, whether there's any heavy metals that are released when we introduce this mineral. So far, based on the laboratory experiments and the beginnings of these mesocosms, all signs are pointing to good, but of course, these are preliminary results. So we're doing very comprehensive ecotoxicology work before we move to full scale. We're also developing a method for measuring, verifying, and reporting on carbon dioxide removal in the oceans, which is also something that hasn't quite been done before. So we're working on building out an integrated system of sensors that will be able to quantify carbon removal, both the rate and the quantity of carbon removal over time, that we hope will help bring our solution to market at scale and also support other ocean-based carbon dioxide removal solutions. So in terms of timeline, we're actually currently not selling carbon removal credits. We did sell to about $250,000 to Stripe in 2020. But we paused there and decided to focus more on research. So we're hoping that we'll be able to start selling carbon removal credits in 2023 when we begin deploying at larger scale. And we have an internal goal of reaching 1 million ton deployment scale by 2026.
In 1 minute, because we want to take
Sure.
one question from
Yes.
Sorry.
No, it's fantastic. So we have we've done a 1/5 pilot scale on a customer site where we made blocks that first runs out of that chamber were within spec. So we were pretty excited. We are now we've done all the engineering and we'll stand up the first 2 full commercial chambers on that customer site in the next 9 months. We'll have a fully de-risked, fully certified process that's generating revenue by spring of next year. And we have 6 customer MOUs behind it just in the Montreal area that we will be standing up pretty quickly after that. So we are heading in the right direction quickly.
Wonderful. I just want to take a moment to thank our audience for submitting so many wonderful questions. I wish we could get through more of them. But I'll start with just one that really is open to all of you guys, and then we'll see if we have time for another. Raluca, I'm sorry if I'm pronouncing your name incorrectly, was noting that the public seems to be more aware of the importance of renewable energies for the future of kind of CO2 reductions, and they want to know how are you spreading the message that carbon removal is a critical part of the puzzle and it's not just about transition to renewable energy sources.
I talk a lot with other companies, and the topic of net zero and how to get there on carbon removal has really kind of taken off over the past year. And as a small company that has managed to get access to organizations like Project Vesta and Carbocrete, I've been able to kind of share my experiences with companies. So hopefully through experiences like that, other companies can learn from Spin's experience and continue to help support carbon removal technology companies that are early stage and help them get to scale. Since we have to remove 10 gigatons a year, and 10 gigatons is 10 billion, I think, tons of CO2. So those are massive numbers. So like Kelly said, it's got to be an all of the above solution. So the more that people learn about it, like Raluca noted, the faster we can get there, hopefully.
Anything you guys want to add?
I think it's through events like this and being able to speak with wider audiences that are interested in supporting the space of carbon removal. If you're getting out the word organically, I think that the net zero commitments that have been made in the last year in the US, I think tripled. And that's really important because it's bringing a level of nuance to the conversation as people realize that not all credits are created equal. But yeah, I definitely commend Agendi for hosting all of us and SPIN for supporting this work, because it is through these conversations that it can get out to a wider audience.
Yeah, hear, hear.
Great. Well, then, Travis, I'll ask you a different question. We have a question from the audience that's curious about how similar your product is to cement. Can it be used for any types of building projects? And you already kind of noted some projects that are currently in development, but I'd love for you to kind of comment on how the amount of CO2 within the cement also maybe influences the product structure.
Yeah, no. So what we make is concrete, right? It's fully valued concrete, calcium carbonate bonds. The product is the same. It performs the same. It works the same. It's not an enhanced product or an alternate method of making building materials. It's we use we switch out cement for slag, but everything else is the same. The process, the product. And plus the CO2 for the curing, but so that's fine. Look, right now it's easier for us to come at this market from the precast or the masonry. It's just the way our technology developed. We're looking at wet cast and other things with reinforcements that as the next phase. But if we did nothing but the billions of tons of concrete blocks that are made, we would make a significant contribution. We have ways that we could cure using sort of more ready mix or pourable concrete solutions. There are also other good solutions out there where people's natural sort of technology set works there. And we some of them came out of the same lab at McGill that ours did. So we are happy to have lots of different solutions. We think we have a particularly good solution for a particularly large part of the market. And ways to sort of advance that, but in the end, the thing that people like about it is exactly the same product. It's stronger, it's cheaper, and it's a heck of a lot better environmentally.
Love that. We'll do one last question for Kelly. Someone from the audience is curious about the environmental impacts of the mining that goes into olivine production. Can you speak a little bit to kind of what that process looks like?
Yeah, so as I mentioned, there are sustainable mining practices that are in development today. There's also mining that's done on only renewable energy. Olivine is done through open pit mining, which is the least environmentally harmful kind of way to do mining. And so it's kind of like at the top level. And then I'll also say that olivine is the tailings of many mining operations. And so we can actually use the waste products of current mining operations and utilize them in coastal deployment. So we're looking at a number of ways to try and be as the least environmentally harmful as we can through mining. Mining has a terrible environmental reputation, and for good reason. But we do think that there's a way to spur innovation in that industry and support it.
So I think the time is over, but I want to thank all of you for your intervention. That was very inspiring. I think, of course, it's frustrating that we cannot go through more questions, but as all of you understand, this is just the beginning of the journey. So at Agendi, our mission is really to connect people and ideas. Agendi, it's a Latin word, it means what needs to be done. And we know that there is a lot of things that needs to be done. So if you were inspired by what you listened today, please reach out to us. We can make any introduction, either to Carbicrete, SPIN to get that feedback, or Project Tester, of course, or other solutions. We did not want to have like 15 people on the panel, but we like to connect people with great ideas to solve the climate crisis. So please reach out and we will facilitate the dialogue. Thank you very much for being here today with us.